Right. We're going to get into comparing ADMs or comparing the average distances from the means. So the idea here is we uh, want to get a sense of which data sets should have larger ADMs and which data sets should have smaller ADMs. So to do this, we are going to look at a variety of data sets. And we're going to look at data sets in pairs. And our job is to essentially figure out which one should have the larger ADM and have some reasoning behind it. So our first data set is a uniform distribution. We have 2 dots at every place where there is a response. And then B is symmetric with a central peak. And we want to know which of these should have the larger ADM or if they should be the same. I've put a little triangle above the 5s. That little triangle here is indicating that that's the mean of the data set. So if we notice this first one, A, the data is sort of evenly spread between, what is that, 2 and 8. So the data is evenly spread between 2 and 8. Whereas for B, the data still spans from 2 to 8, but most of the data is in the middle, right? So the data spreads from 2 to 8. But most is between 4 and 6. So in A, the data is spread out sort of across the board, whereas in B, the vast majority of the data is clumped very close to that 5. And then we have a few stragglers on each side. So if we wanted to talk about a typical distance from the mean, A has more points further out. And so our sort of typical distance is probably going to be larger, whereas B, so many points are very close to 5, our typical distance from that mean is going to be fairly small. Right? So in this case, it's clumped close to the mean. So between these 2 data sets, I would say that this should be the larger ADM. And this will be the smaller ADM. If we look between C and D, what's going on in C? So in C, the data spreads from 0 to 10. But almost all points are right at the mean. So in other words, all but two of the points are distance 0 from the mean. Now in D, the spread is smaller, right? We go from 1 to 9 instead of 0 to 10. So the data spreads from 1 to 9, but almost all points are far from the mean. Right? 8 out of our 10 points are distance 4 from the mean. So if we were to take the average distance, in C, so many of the points are close to the mean, they outweigh those 2 points that are far. Whereas in D, we have a lot more points far from the mean. They outweigh the stuff that's close. So the far points outweigh the close. And by far and close, I'm talking about how the distance from the mean. Whereas in this case, the close points will outweigh the far. Now, to be absolutely positive, you would probably have to calculate the ADM. It's certainly possible to pick 2 points that are so far away from the mean that they still manage to give a large ADM. But in this case, they're close enough in if we did actually calculate our ADMs. This certainly would be our smaller ADM. And this will be our larger ADM. Our last pair. This is the first set that I have shifted our graph so our mean is no longer 5. So E, the mean is 6, and in F, the mean is 4. So E, this point spread from 4 to 8 versus in F, they spread from 2 to 6. But if we look at our means and we talk about the distance from the mean, they're essentially the exact same thing, right? In both sets. So in both of these, we have 4 points at the mean. In both of these, we have 4 points that are distance 1. And in both of these, we have 2 points that are distance 2. So if we ignore the actual numbers and just look at the distances, these are essentially the same graphs when it comes to spread, right? So because these have the same distances, the distances from the mean match, these actually have the same ADM. So the key thing for E and F, it doesn't really matter when we talk about ADM, it doesn't matter where on the number line our dots fall. It's more just specifically how spread out those dots are wherever they fall on the number line. Right, so this is just sort of looking at how we can go about comparing ADMs. It's just focus essentially on where is most of the data. If most of the data is far out, then it's a larger ADM. If most of the data is close in, it's a smaller ADM. If it's sort of an even spread across the board, it's going to fall somewhere in between. We've got some dots close and some dots far. So this is playing around with the ADM. And in our next video, we will now switch to the more standard measure of spread, which is standard deviation.